Welcome. This is Engineering Mechanics Class 51, Part 2, Lecture number 11. I have taken around 2 weeks break for some reasons. Now class will continue almost on daily basis. See, first, today what I am covering is law of triangle of forces. Written here, law of triangle of forces. Then one very important theorem called Lami's theorem. In between, there is one more, law of polygon of forces. Law of triangle of forces, I have written everything here. I will explain. Those who find difficulty, go through the class again and again and understand. I won't repeat. Law of polygon of forces, I will explain here. Statement, I will dictate. By seeing here only, I will dictate to save the time. Okay, now, first, law of triangle of forces. Remember, it can be told in two different ways. One of them is for finding resultant. That is not equilibrium. But other one is law of triangle of forces for equilibrium. Now remember, if it is equilibrium, there is no resultant. Therefore, when you apply law of triangle of forces for equilibrium, three forces are considered. Three concurrent forces are considered. Why? Three forces, three sides. But when you consider law of triangle of forces for finding resultant, only two forces. What is the reason? First force, say P1. Second force, P2. Not third force, because forces P1, P2. Now resultant is there. For resultant, we need one more side. So if you consider a triangle, here two sides are for the forces, one more side is left out, that is for resultant. Here, there is no resultant. So this is for three forces. So remember, how to remember is, if you apply the law of triangle of forces for resultant, resultant also comes. So three forces are there, two are the given forces, one is resultant. So for law of triangle of forces for finding resultant, only two forces. Reason, one reservation required. Last one is for resultant. But if it is for equilibrium, no resultant, law of triangle of forces is for three forces. Same way, little later, I will tell now. Law of polygon of forces. See, no restriction, any number of forces. I will explain now only. See, suppose there are n number of forces, n, anything, starting above 2, anything up to infinity, n number of forces. Then, if it is applied for finding resultant, one more force will come, resultant. So, the regular polygon should have n plus 1 side. But if you apply same for equilibrium, no resultant, the polygon will have n sides only. That is C. Law of triangle of forces, general, is for two forces. But some will tell, sir, triangle, three. Okay, two forces, next one is resultant. And equilibrium, three forces. Why? There is no resultant. Suppose there are 8 forces are there. I am going to law of polygon of forces. 8 forces are there. 8 forces plus one resultant will come. So if there are 8 forces are there, the regular polygon should have 8 plus 1, 9 sides. The 9th side is for resultant. But if the 8 forces are in equilibrium, there is no resultant, then the regular polygon will have only 8 sides. I will first explain law of triangle of forces, then I will go for law of polygon of forces. But remember, law of polygon of forces in the class, I will dictate, you should write it. But in the notes, I will write everything. Okay, start. Law of triangle of forces for finding resultant, or general, in general. If two forces acting through a point can be represented both in magnitude and direction by the two sides of a triangle taken in order, very important, see, taken in order, then the resultant is represented both in magnitude and direction by the third side of the triangle taken in reverse order. very, very important. Two sides you should take in order for the two forces, P1, P2. Then resultant is not same order, reverse order. I will explain to that one. Now start. You can write either proof or explanation. See, you can write here. This can be told as a proof or explanation. Anything you can write. Consider two forces P1 and P2. Angle theta, resultant alpha, etc. not required now. Consider two forces P1 and P2 passing through a point O. Let R be the resultant force as shown. This is P1, P2, this is R. Now see, I will dictate something. First what you do is, represent P1, you should write. See, what I am dictating, you should write. If you are not writing, you are losing, that's all. Represent P1 by OA. OA, okay. I'll put O here, A. This is P1. This you already know it. Represent P2 by OB. See, it's a small sketch here, space problem. P2 by OB. Okay. Now, complete OA, OA, OB. Okay. Right here. After all this one, you should write represent P1 by OA, represent P2 by OB. Complete the parallelogram. Parallelogram is called OACB. This all you know earlier. Then you should write statement. Then OC represents the resultant. Resultant R. Why? In the bracket. By law of parallelogram of forces. So therefore, this will give resultant. This is well known to you. Now do one thing, correctly observe. See, now right here, we know that your OB equal to OC. See, OB equal to, sorry, not OC, OB equal to AC. OB equal to AC, equal to P1, P2. Therefore, now you draw below one more sketch. Now you should draw one more sketch where you mark this as P2. See, if this is P2, this is also P2. Now consider only triangle. Now consider triangle OAC. OAC. Some statement I am giving now. See, in the triangle OAC, OA represents force P1. You should write. Those who are serious, those who are not going for notes and want to learn everything should write what I tell. In triangle OAC, OA represents P1. AC represents P2. So in order, see, OA in the same order, AC. Then if you continue in the same order, you should come back here. See, OA, AC, same order is CO. But no, resultant is OC. Starting point to next second point to third point. In the same order means third point to once again starting point. No. Third side is, see, starting point to first point to second point. Then once again, starting point to ending point. Therefore, OC. Therefore, see here, OA represents the force P1. AC represents the O. You should write. It started raining here. Hope there is no disturbance. OA represents P1. AC represents P2. In order you are taking now, in order. In the same order, next is CO. No. Resultant R is OC. OC represents resultant. That much is sufficient. See correctly. OA, AC and C. Actually same order means OA, AC, then CA is the order. See. OA, AC, CO. No. OA, see here. OA, AC, change the order. OC. It is a, when you consider a triangle, when you go round, in order is CO, reverse order is OC. this one. Or you can tell one more thing, see, or simply, see, P1, P2, P2. See, P1, P2, then this is the same order. No, this is the resultant order. This is law of triangle of forces. Okay. Now, this is law of triangle of forces when there are two forces. Now, consider law of triangle of forces for equilibrium. As I told already, if it is in equilibrium, there is no resultant. So, not two forces, three forces. See, law of triangle of forces for equilibrium. The rain started more, so I will explain this one and then pause the recording. Law of triangle of forces for equilibrium. If three forces passing through a point are in equilibrium, then they can be represented both in magnitude and direction by the three sides of a triangle, this time taken in order. Very, very important. Taken in order. I will pause because rain increased here. Sounds are coming, disturbance is there. When the rain reduces, anyway, for you, it does not matter. Now, I will go for law of triangle of forces for equilibrium. As I told, three forces are there. If three forces passing through a point are in equilibrium, remember, this is applicable only for equilibrium, then they can be represented both in magnitude and direction by the three sides of a triangle, now this time taken in order. Now, either you tell proof or explanation. See, consider three forces, P1, P2, P3 in equilibrium as shown. I forgot to put the sketch there. Sketch is here. See, right mark. Put a right mark here, not right mark. This sketch you write here. Now, see, represent P1 by OA. See, P1 by OA. Represent P2 by OAC. This is actually OAB I can write, but last time C. So, okay, C. Represent, my wish, after A I will put C. Represent P1 by OA. Represent P2 by AC. Now, then do one thing. Right now, forget about P3. Consider only P1 and P2. Then P1, then OC, see, OC represents the resultant for P1 and P2. See, P1, P2, reverse order. OC represents resultant. How? As shown. Y represents just now over by law of triangle of forces. Now, very important statement. See, OA in order, AC in the same order, not same order, reverse order, OC represent resultant for P1 and P2. Now right here, but the three forces, P1, P2 and P3 are in equilibrium. Therefore, you should write here, therefore, P1, P2 and P3 are in equilibrium means therefore, for P1 and P2, see, P1 and P2, P3 should be equivalent. I already told you, equivalent is that force which is in such a way that it will reduce the system to equilibrium. So, for OA, for P1 and P2, resultant will go this way. So, P3 should be equivalent. Okay, now see, therefore, we also know that equivalent, you should write, no space here, should have same magnitude as resultant but in opposite direction. So therefore, whatever R you got, its opposite direction should be P3. Therefore, this R in reverse order, if reversed, this R, if reversed, should correctly match with P3. Okay, this is law of triangle of forces for equilibrium, or simply you can tell, see, P1 by one side, P2 other side. If it is equilibrium, resultant should not be there. Last force should correctly come and join the first point. Simple to understand. So this is law of triangle of forces, here for two forces, here for three forces. Two forces because one resultant is there. Three forces because there is no resultant. Now I will go for next. I will dictate here, or briefly I will explain, not much. I will explain very briefly. Law of polygon of forces. Law of, actually not required, law of polygon of forces. Again, once for resultant, then law of polygon of forces for equilibrium. See, I will dictate here in the class. In the notes I will write everything. Statement, see, statement. If n number of forces acting through a point can be represented both in magnitude and direction by the n sides of a, not triangle, of a regular polygon taken in order, then the resultant is represented both in magnitude and direction by the large side, n sides of a polygon, one is here, n side of a polygon, one extra you have to add here, n side of a polygon of sides n plus 1. Why n plus 1? N forces, one resultant. If n number of forces acting through a point can be represented both in magnitude and direction by the n side of a n sides by direction by the n sides of a polygon which has number of sides n plus 1, then the resultant is represented both in magnitude and direction by the large side or n plus 1 side, but in reverse order. I will explain this one. Reverse order. Here, law of polygon of forces for equilibrium. If n number of forces, space problem, I write here. If n number of forces passing through a point are in equilibrium, then they can be represented both in magnitude and direction by the n sides of a polygon of sides n only, of number of sides n, of number of sides exactly equal to number of forces, of number of sides n equal to n. Okay. Remember here it is not all that important, but in the notes I will write systematic way everything. Now I will explain that one. What is the meaning? Just briefly. Both I will explain. See, for explanation, I will take 5 forces. Consider 5 forces. See, P1, P2, P3, P4, and P5. Let there be 5 forces. 5 forces. See, now passing to a point O. First, you apply the first, what I wrote here. First you consider law of, you write everything you write. First you will consider law of polygon of forces for finding resultant. Therefore, if 5 forces are there, we require 6 sides. There should be a polygon of 6 sides. See, start from here. Represent P1 by OA. I start from here. see, parallel to this one, OA, P1 OA. Represent P2 by OB, OB, P2. Represent P3 by OC, slightly this way. Oh, okay, whatever way is there, okay. P3 by OA, OC, BC. Represent P4 by CD, P4 by CD. Represent P5 by this way, okay, this way, by DE. Now see correctly, one side is still pending. Now see, by law of triangle of forces, see correctly, for OA, for P1 and P2, OB is the resultant. This is the resultant. Say R1, resultant R1. Then for R1 and P3, this is the resultant. R2. Say R2. Then for R2 and P4, this is the resultant. R3, R4, R3, okay, R3. R3 is the resultant. Then for R3 and P5, for R3 and P5, this is the resultant, which is the final resultant for all forces. Therefore, see, represent P1, P2, P3, P4, P5. Same order is this way: OA, AB, BC, CD, DE. Then reverse order, OE is the final resultant. This is law of polygon of forces. I explained for 5 forces. Now I will go for equilibrium. Now, again consider 5 forces. But this time in equilibrium. Therefore, this time there is no resultant. So your polygon should have only 5 sides. Start. I will mark the forces. P1, P2, P3, P4, P5, I will write last. Okay, I will write last. I should match it. Start. O. Represent P1 by OA. OA represent P1. Represent P2 by OB. AB. Represent P3 by BC. Represent P4 by CD. Which one? P4. Okay, now I will put P5 here. This is your P5. Now, if the system is in equilibrium, P1, P2, P3, P4, this in order OA, AB, BC, CD, in reverse order, this should be resultant. Put a sketch right there. This is the resultant for P1, P2, P3, P4. Write one more sketch, tell, but there is no resultant. So P5 should be equal to R, but magnitude, but opposite in direction. Write one more sketch, then tell this should be your P5. Or if you start from here, see where is the ending point. If you join starting point to ending point, it will give you resultant. If the ending point comes once again to starting point, there is no resultant. Such a simple one. Understand, here sufficient. Difficulty means go through again and again and understand. Okay, now I will go to next one. This is briefly I told the most powerful theorem That is called Lami's theorem. I will write in board neatly and start that one. Now, one of the very powerful theorems in engineering mechanics, that is Lami's theorem. First I will read statement. See, simple statement. If three forces passing through a point are in equilibrium, then each force is proportional to sine of the angle between the other two forces. So first you have to make a note. Lami's theorem is applicable only for three forces, and it should be passing through a point. It is not applicable for general coplanar. It should be concurrent. Three forces are there and they should be in equilibrium. Very important. It is applicable only when the three forces are in equilibrium. Okay, now, explanation. Consider three forces P1, P2, P3 passing through a point O as shown. That point O be in equilibrium. So that will be P1, P2 and P3. Next, see now correctly, for P1 you take angle theta 1 between the other two forces. Make a note. For P1 the angle to be considered is between P2 and P3, theta 1. For P2 between P3 and P1, theta 2. For P3, theta 3 between P1 and P2. I written here. See, let theta 1 be angle between P2 and P3, theta 2 be angle between P3 and P1, theta 3 angle between P1 and P2. Easy. See, theta 1 without seeing there, theta 1 between 2 and 3, theta 2 between 3 and 1, theta 3 between 1 and 2, as shown. Then Lami's theorem, by Lami's theorem, what he told? Each force is proportional to sine of the angle between other two forces. Therefore, P1 by sine theta 1 equal to P2 by sine theta 2 equal to P3 by sine theta 3. This is as per Lami's theorem. Okay, now proof. Simple proof. Since the three forces are in equilibrium, they can be represented both in magnitude and direction by three sides of a triangle taken in order. This you know, this is by law of triangle of forces right here. This is by law of triangle of forces for equilibrium. Just now we finished it. Now, what you have to do is, see. Now, some statement I have to write here. See correctly. Represent. See the order. What way I explain, that way you have to write. Right. Not seeing here. Represent P1 by OA. See, P1 by OA. Represent P2, same, P2 by AB. And P3 by BO. So finally, it should come back here. Then, extend in the same order. This sketch you write here. Okay. Write this sketch. After the statement, write this sketch. Then write extend OA, AB and BO, same order, as shown. Now I will do one thing now. I will remove this one now, not required. This is not required now. See, finally what you have to prove? You have to prove P1 by sin theta 1 equal to P2 by sin theta 2 equal to P3 by sin theta 3. This I will remove. Okay, now I will put the sketch once again. One more sketch. See, this is AB, P1, this is AB, then, no, not that way. P1 is here. OA, okay, no problem. See, this is OA, same way, OA representing P1. This is, it comes this way, correct? Okay. This is up to where? Little bigger. Okay, then this is somewhere here. P2 represented by AB, and this is back here, P3 represented by this way. Now, see correctly, extend this line in the same order. Extend this line, extend this line, and extend this line. This is not 90 degrees. Now see correctly. Theta 3. See here. Theta 2. Theta 1. Theta 1. Now, if this is theta 1, this will be equal to 180 minus theta 1. If this is theta 3, this is 180 minus theta 3. If this is theta 2, this is 180 minus theta 2. Okay, write this sketch right here. Then I will remove this one now, not required. Then we have by sine rule applied for triangle. I make a small note if you want. See, suppose in general, don't see here. In general, if you draw a triangle ABC, little bigger I'll put here to understand. Okay. If you draw a triangle ABC, this is called angle A, this is called angle B, this is angle C. For angle A, this is side A. For B, opposite side B, side C, we have A by sine rule. By sine rule, this side by sine of this angle. A by sine A equal to B by sine B equal to C by sine C. This is angle C. Now right here. Therefore, if you see here, see now, by sine rule for this sketch, see here, P1 by, or you write, okay, OA divided by what? OA divided by sine 180 minus theta 1 equal to AB divided by this side divided by sine, I will remove this one now, not required, sine 180 minus theta 2 equal to BO divided by sine 180 minus theta 3. Now, OA equal to P1, see, and this AB equal to P2, and BO equal to P3. Also we know that, see, we also know that from trigonometry, in general, sine of 180 minus theta equal to sine theta. You should know this one. Sine 180 minus theta is sine theta. Therefore, sine of 180 minus theta 1 is sine theta 1. Sine of 180 minus theta 2 equal to sine theta 2. And lastly, sine of 180 minus theta 3 equal to sine theta 3. You write all these and then write, therefore, conclusion, see, therefore, in red color I will write here now. Therefore, see, OA equal to P1. P1 by sine 180 minus theta 1 is sine theta 1. Sine theta 1 equal to AB equal to P2. P2 by sine theta 2 equal to, see there, P3 by sine theta 3, which is what we have to prove. Right here. This is to be proved. This we got. This is what we have to prove, because in the beginning I told, by Lami's theorem, this is a statement. Now proof. Finally, we got the answer. Therefore, remember, if three forces P1, P2, P3 are in equilibrium, passing through a point, any point, if theta 1 is angle between P2 and P3, theta 2 is angle between P3 and P1, theta 3 is the angle between P1 and P2, or angle considered are between other two forces, then P1 by sine, each force is proportional to sine of the angle between the other two forces, or P1 by sine theta 1 equal to P2 by sine theta 2 equal to P3 by sine theta 3. Rain disturbance is still there. I waited for a long time. It is actually around 2:30 a.m. now. 2 hours I waited. The sound is still coming. Then I decided, because already I had taken a two-week break. Now I decided to upload daily classes. More rigorously I'll upload. Therefore I decided, okay, that disturbance is not a big disturbance. You can hear the voice clearly. So do not put any comment that disturbance is there. It's a minor one. See, here important is what? Important is what I tell, you should hear clearly and understand. Subject knowledge important, not one sound coming there, not there is one dot here. This is for camera purpose. Some dots are there. Why should you bother about dots are there? Okay, now I'll conclude the class here. Today we considered what? Law of triangle of forces in two different ways. Once for resultant and then for what? Equilibrium. Law of polygon of forces, once for resultant and one for equilibrium. Lastly, Lami's theorem. Next class, next 1 or 2 classes, we will apply Lami's theorem to solve many examples or problems. Okay. Thank you. I'll upload in the next classes.